Oftentimes when we solve problems, we have to use a new math skill. And so here we're going to learn about how to use the quadratic equation to solve a problem. So here's an example problem. Suppose we have a ball and it's launched with a vertical velocity of 46.8 meters per second. So that means that when it's launched right here, the upwards velocity in the y direction is 46.8 meters per second. The ball starts at a height of 30 meters and it lands on the ground. So the ball starts up at here at 30 meters and it goes up, 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 up and lands on the ground. And we want to know, among other things, how long is it in the air? So how long it's in the air depends on the y problem. So delta y is the distance it travels in the y direction. So it starts here and it ends up down here. So delta y is negative 30 meters. The velocity in the y direction initial is what number is given right here. It's how fast it's moving vertically at the beginning of the problem. So that's about 46.8 meters per second. We do not know how fast it's moving downwards when it gets down here, but we do know that the acceleration in the y direction is negative 9.81 meters per second squared. And that's all we have. So we're going to try to solve this equation for the time t. So our plan is going to be to solve this equation. All right? Now, with horizontally launched projectiles, this middle term was 0, so we could just solve for t directly. But now it's not. The initial velocity in the y direction is not 0. And so this term doesn't go away, so we cannot solve this for t directly. We're going to have to use the quadratic equation. So I'm just going to kind of walk you through how we do that. So what I'm going to do is I'm going to plug in the numbers right now. We're not going to try to solve this algebraically. That becomes a bit of a bear. But let's plug in the numbers. So delta y is negative 30. The velocity in the y direction is 46.8 times t. 1/2 of the acceleration is negative 4.905. So 1/2 of 9.81 is 4.05, and it's negative. And then you've got a t squared. So what I did was I just put in delta y, I put in the velocity initial in the y direction, and I put in 1/2 of a, and I got this equation. So this is what we call a quadratic equation. We have both t and t squared. To solve the quadratic equation, we have to rearrange it so that one side equals 0. So I'm going to add 30 to both sides to bring this to the other side, and it will look like this. And you probably remember vaguely from math, but when we are solving the quadratic equation, we have to identify the coefficients a, b, and c. A is always the coefficient of the term that is squared. So in front of the squared term, we have negative 4.905. So that is going to be a in our quadratic equation. B is always the coefficient of the term t to the first power. We call it the linear term, and that's right here. So that's going to be b. And then c is always the constant term, the term that has no t's in it. So that's going to be c. And remember, you've got to rearrange this so it all equals 0. You're going to have a rough time if you forget the negative here. Bring it to the other side and make it negative. So you'll get the wrong answer. So here's what we're going to do. We're going to solve this equation. So you may or may not remember, and if you don't remember, it's okay. It should be in your toolbox under handy math formulas. But the quadratic equation looks like this. To find t, or whatever it is that the variable is, you got to take minus b plus or minus the square root of b squared minus 4 times a times c, and that is all over 2a. And then a, b, and c are these coefficients. And we're going to get two solutions. We do it once with the plus and we do it once with the minus, and that'll give us our two solutions. So in this case, what I'm going to do is I'm going to take negative 46.8 plus or minus the square root of b, which is 46.8 squared, minus 4 times a, which is negative 4.905, times c. You've got to make sure you group these things. All of this is in the radical. And of course, all of that is in the numerator. Then you've got to divide it by 2 times a. Okay? When I plug that all into my calculator, and this is going to take some practice, so that's why we're doing it today, I get two solutions. One is negative 6.03, and the other is 10.1. So you can stop this and try that and see if you can get those solutions. In this case, because we're trying to find the time, we're going to keep the positive solution. But there are two solutions to the quadratic, one for the plus and one for the minus. So there you go. That's how we're going to solve the quadratic. And then later on the next homework assignment, we're going to use it to help solve other problems that involve projectiles. So let's just do it one more time with a practice one. There's some notes in case you're looking at this later. Let's suppose I want to solve this quadratic equation. Okay? I've got w squared, I've got w, and I've got a constant term, and it all equals 0. So I have to identify a. A is the coefficient of the term that is squared. So a is going to be negative 16. B is the coefficient of the linear term that just has w to the first power in it. So there's b. And then c is the constant term. So a is negative, b and c are both positive. So I'm going to use the quadratic equation, which looks like this. When I plug in my numbers, put in 64 for b, negative 16 for a, 96 for c, I get this expression, and I plug that all in my calculator, and I'm going to get two answers. I'm going to get 5.16 or negative 1.16. Okay, so that's what we're going to practice today. We're going to practice solving the quadratic equation because we have to do it reliably and accurately in order to solve projectile problems. Now, if you have a graphing calculator, there is an easy way to evaluate this, and I just want to show you how. If you don't have a graphing calculator, you can stop the video and go ahead and get to work. But if you have a graphing calculator, this will save you some time. Here's what I'm going to do. A is negative 16. So I'm going to take negative 16 and store it in A. The store key is this button right here. So if you type negative 16 and then hit this key, it'll allow you to store it. And if you hit alpha, once you hit alpha, this key next to it turns into an A. You can store it in A. You can then store 64 in B, and you can store 96 in C. So now A, B, and C contain your coefficients. Then you can write the quadratic formula exactly as it appears right here. You can take minus b plus the square root of b squared minus 4ac. All of that's divided by 2a. And when you hit enter, it will plug in A, B, and C that are stored, and it'll give you the answer. You can then recall this. So to recall this expression, hit the second key and then hit enter. That recalls the last expression. Go change the plus to a minus, and you'll get the other solution, 5.16. So by storing the values of the coefficients, you can quickly evaluate it. And then for the next one, you could store new values, and then just scroll up and grab this expression and evaluate it again. Okay, so that's a pretty quick way to evaluate the quadratic equation if you're using a graphing calculator that allows you to store values. All right, so you're going to practice some problems now, get to work, and see how it goes.